Hello, everyone. All right, I think more and more people are joining. Maybe let's wait for another minute and then we can start. I hope everyone is feeling good. Have some coffee on the table and then yeah, let's wait for another minute and we can start. Maybe some note in advance. If you don't have an existing GitLab.com account, please go to gitlab.com/users/sign up and then you can create a new one. Yeah, we need the account for our hands-on session. Uh, and yeah, let's wait some couple of seconds and then let's kick it off. All right, let me check how many participants are online. Okay, some more folks are joining. And yeah, with that, uh, let's kick it off. First, we have some housekeeping information. We will record the session and we will also provide you the link afterwards. We also do some breaks between the different hands-on sessions. And whenever you have questions, please use the Q&A section for Zoom. And yeah, with that, welcome to our GitLab CI workshop from community to premium. My name is Johannes Bauer. I'm customer success manager for the EMEA DACH region, and I'm thrilled to guide you together with Claire through this workshop today. Claire, would you like to introduce yourself?
Hi, yeah, my name is Claire Marie, and I'm a solutions architect with GitLab. I come from a development background before I transitioned to the dark side.
Good. Thanks, Claire. And
I'll
yeah,
take.
with that, Sarah, you can also introduce yourself
I
and
just wanted to
and
say a
Joey.
quick hi, no worries.
Yeah,
So, hi, I'm Sarah.
so,
You will not see me too much today as I'm covering the question and answers, but it's great to see so many people here. So, well, thank you, Johannes. Go on.
yeah, then Seraphine, maybe you would also introduce
Yeah.
yourself and then
Uh,
we can start.
yeah, I'm sorry. Hi, I'm Seraphine Young. I'm a dev architect. You will not be seeing me much on camera today, but I'll be in the back end making sure the systems are working. But I'm going to
Yeah.
be in the chat too, so say hello.
And whenever you have any questions, Sarah and Seraphine are happy to answer. Please use the Q&A section. And yeah, with that, before we dive into the workshop, we are thrilled to announce that GitLab has been recognized as the leader in the Gartner Magic Quadrant for DevOps platform. And we feel this is really an important recognition. And yeah, it's really cool. And it highlights out our commitment to delivering software, enhance security, and also drive innovation for our customers. And with that, I will give you a short introduction. So we are all new team members working for a brand new startup. It's yeah, and startup has built up the new racing game Tanuki Racing, and we are already currently using GitLab CE, but we are planning on upgrading to GitLab Premium to take the advantages of the advanced CI/CD features. And we all have been tasked with learning about the various pipelines capabilities. And yeah, this is our task for today. And we'll go over different sections. And with that, let's do our first lab, our setup lab. we need, in this section, I will walk you through how to get our lab environment, and we will set up. If you have any questions, please go to the Q&A section. And as I already told, Sarah and Sophie are happy to answer everything. So the first, what we need to do is please go to gitlabdemo.com. I will also paste the link into the chat. Thanks, Seraphine. She already posted into the chat. Click redeem the invitation code. Use the invitation code, Seraphine, paste it in the chat, and register. So you also need your gitlab.com ID. If you don't know where you find your gitlab.com ID, open a new gitlab.com tab, click on your avatar on the left side, and then the ID is everything after the some symbol. And yeah, once you have redeemed the invitation code, you have to click provision training environment. Then you have to go paste your gitlab.com username. And if everything works well, you should get an overview like this, where you see our current lab and also your GitLab URL for the environment we set up. And I will also do this now. So I will also click redeem invitation code and then paste the code. So if you don't know your username, go to gitlab.com, click on your avatar, and then it's everything after the symbol. So in my case, it's Jobauer, and then click provision training environment. And yeah, now I have the overview for our CE2 Premium workshop for today. And you can click to the GitLab URL for this special environment. And yeah, with that, we have everything set up. If you receive an 404 error, then you may have misclicked somewhere. Please make sure that you have the correct GitLab account. And yeah, with that, let's wait some seconds, and yeah, maybe everyone can paste thumbs up or or something else, that we make sure that everyone is on the same page and we set up our environment correct. I will wait now for some couple of seconds. And if you have any questions, please use the Q&A section, and Seraphine and Sarah are happy to answer everything. Thanks, David. Maybe Danny, I saw that you get on 404 error. Maybe Sarah and Seraphine can help you.
I'll message him.
All right, let's wait maybe for 10, 20 seconds, and then let's move forward. So once you have enrolled, you should get this overview, and also should have the GitLab URL where you set up your environment. In my case, it's this test group, and there's also one project in this group. Right. And with that, we are hopefully now have all set up for our hands-on lab. And yeah, let's start why GitLab Premium is adding value to your organization as they move from the community from the community edition to Premium. At a high level view, we categorized these features into main categories. One big topic is the faster code review, which includes better code controls, code review analytics, and code quality reports. B, advanced CI/CD features like operation and environment dashboards or merge trains. And C, enterprise agile delivery features, for example, push rules, approval rules, or merge request dependencies. And we are going to test out some of these features in the handoff sections, but we are not able to cover all of these features. And looking ahead, upgrading from GitLab Premium to GitLab Ultimate unlocks even more advanced capabilities, such as deeper security integration and comprehensive compliance management. And when you're thinking about better code controls, what you maybe probably think of is better collaboration, code being reviewed by experts in that domain and also knowing who they are, but also protecting the default branch by having rules put in place to prevent untested or unauthorized merges. And finally, security and compliance measures can be implemented to reduce the risk of exposure. And GitLab Premium has these features already baked in, which you can start leveraging into your workflows. And this is what we are doing in the handoff sections. And on this slide, I've highlighted out some of the advanced CI/CD and agile delivery features, which including merge trains to reduce pipeline queue times, connecting to external CI/CD projects, and leveraging GitLab CI/CD pipelines for building and development. If you would like to get a more detailed overview of these and other premium features, we have a dedicated page for this. So feel free to take some time to explore it. And one thing I always emphasize to my customers is that adding new features is great, but it's also crucial that they bring real value to your organization. So start first by identifying the specific value you would like to achieve, then quantify it, and then select the press product or feature that meet the goal. So yeah, it's cool, or it's great to add new features, but they also have to bring a real value to their organization. And with that, let's go to our first lab, execution order, allow failoring and caching. This is where we are in the agenda right now. We will talk about starting pipeline, code controls, merge train, usability and security, and at least also transfer the project and give you some conclusion. So in our first lab, we are a new CI/CD developer, and the product manager asked us to test some of the different types of pipelines that are available in GitLab to figure out what suits our needs best. And the first task we get is to get a simple starting pipeline up and running, and we will be working through some more advanced topics from here. So let's refresh some basic CI/CD components. Pipelines are the top level CI component in CI/CD, and pipelines comprise of jobs which define what to do and stages which define when to do jobs. Within the job statement, we have the script, the before script and the after scripts keywords. And these are important, especially when you have scripts that depend on each other. And the before the script keyword is only the required keyword that the job needs. So without it, the job wouldn't have anything to do. The before and after scripts keywords are optional. And before and after script keywords are pretty much do what they say on the fin. So the before script runs before the script statement will be executed, but in the same shell. And its main purpose is to execute steps that are necessary in order for the script statement to run properly. For example, if you would like to use AWS CLI command in the script statement, then you have to install the AWS CLI in the before script part, and to make sure that you can run the AWS CLI command in your script. And you can use the after script, for example, for clean up things and remove some temporary files or whatever. And within a pipeline, a job is only evaluated as passed or failed based on the exit code of the regular skip statement. Yeah. And with that, let's talk a little bit more about execution order. By default, each job in each stage gets executed in a sequence, but we can also manipulate the execution order to help to speed up things in the pipeline in a variety of ways. And one way is, what you can see here is that the initial state of the CI/CD execution, the job in the test stage, will execute it once the jobs in the build stage are completed. And you do have the freedom to adjust the execution order based on your needs. And this is one one new keyword, the needs keyword. You can use the needs keyword when you would like to adjust when you would like to run pipeline. By default, as I already said, pipelines run on a sequence basis. And in the example on the screen, you can see that the code quality step, which is here defined, has an empty needs keyword, and an empty needs keyword means it will run as soon as the pipeline gets kicked off. As some of these tests can make a wide run, this can be greatly speed up the runtime of your pipeline if you have more tests. And using needs keyword can be a way more powerful. You can also specify a dependency on another jobs. For example, if you run DAS, Dynamic Application Security test stage, you can make that dependent on the build app being created first. So yeah, that's really nice feature, and you can create dependencies based on the needs keyword. And what we also introduced in GitLab 14.2 is it's called stageless pipelines. So rather than specifying the different stages like build, test, and security, you can use the needs keyword to specify the dependencies and let them be in charge of the execution order. So in this example, we don't have any stages. We just have some names of the jobs, and then the different scripts what should be running. In this case, we do only have some outputs, and we tell in the unit test job in the needs keyword that the previous job which needs to be executed is the build job, and in the deploy job we say the unit test job has to be run successfully before we start the deploy job. And it's quicker to write to. With that, let's move to GitLab runners. GitLab runner is the application that makes running the pipelines possible. And there are a bunch of different types you can use, and they can be scoped on the project level, on the group level, or shared across an entire GitLab instance. And if you would like to learn more about the GitLab runners, please go to our documentation page at docs.gitlab.com/runner. There you will find more information regarding GitLab runners. For our test environment today, we set up shared runners on the group, and we don't have to be in mind what it means for the runners. We just click on the run button, and then the shared runners we set up for you will take these jobs and run the jobs. And the jobs typically picked up within 5 seconds, depending on how many people are hit the run button at the same time. So today it can be maybe take some more seconds because we have a lot of folks in the workshop today, and yeah, once every runner is running, then maybe it takes a little bit more, but yeah, typically jobs are picked up within 5 seconds. Let's talk more about runners and about the configuration of runners. The way you can configure your runners can be as flexible as you need. So some of the most used config options are listed on the screen here. And for example, you can tag runners. We can also tag jobs. We can define job timeout, script timeouts, or also protect sensitive information. And what's also really cool is if you are running runners on AWS, you can even leverage auto scaling to make sure that you always have the correct amount of runners to meet your needs. So, for example, if your team is based in Europe, then maybe you need up to 100 runners each day. And with AWS, you can leverage auto scaling and make sure that you have the number of runners available if you need, and when it's in the night, then maybe you don't only need 10 runners, then the autoscaler will also decline the runners and remove the runners that you don't that you save time and don't waste money. And with that, let's talk a little bit more about GitLab runner executors. So GitLab runner implements a number of different executors that can be used to run your builds in different environments. For example, shell runs commands as you were writing them into a terminal or a command prompt or a PowerShell. Docker runs job on a Docker images. And even though Docker deprecated Docker machine, we maintain a fork for GitLab runners so that you can use also the Docker machine executor. And you can also use Kubernetes executor to use Kubernetes cluster for your builds. And if you would like, as I already told, if you would like to get more information about the GitLab runners executors, go to our documentation page, and there we will all the information about GitLab runner executors. And another way to speed up pipelines is by leveraging caching. And caching helps to improve the efficiency of your pipelines by storing reusable files in an S3 bucket and reducing the time spent on repetitive tasks and speeding up builds. And yeah, it's also really crucial when it comes to saving costs and also time. On the left side of the slide, we see the execution order. Let's go through this order shortly. The pipeline starts and the first job A is executed. If a cache is available, it is extracted. Then the before script is executed, preparing the environment, installing some packages and some libraries. Then the script section where the main job logic residues is executed, and the after script runs, performing any cleanup or additional task. And finally, the cache is saved with the contents of the specific directory being zipped into a cache.zip and stored. And then the second job B, follows a similar process. It extracts the cache if available, runs its before script, and executes its main logic in the script. And the pipeline finishes once all jobs are completed. So to get a more real example, on the right side, you see a GitLab CI.yaml configuration. The pipeline is divided into 2 stages, the build and the test stage. In the default section, we define the cache settings. The key ensures that we have a unique cache identification, and the path specify the directories to cache. In this case, it's called the vendor folder. And we have a before script which issues a message, hello. And then we have in the job A, in the build stage, we have only a script which creates make directory vendor, and then also creates an issue build and save this to the vendor hello text. And after script, we also say get on Hello World. And the job in the test, the job B is in the test stage, and it accesses the cached file created by job A to verify its content. But why is cache necessary? With cache, you can share downloaded content between different jobs. You can also store code dependencies, so you don't have to wait for them to download next time. Then you have different jobs with the same dependency are necessary, then you don't have to wait. And it also increase the pipeline speed and save costs and speed up things. And what are the difference between cache and artifacts? So cache, or the definition for cache is when a job doesn't rely on the output of another job, but would speed up by having access to it, then you would choose the cache. And you choose artifacts when a job is dependent on the output of a previous job, then you use artifacts. And we also have a simple sentence to remember if you're struggling between choosing cache and artifacts. So cache is here to speed up the job, but it may not exist, so don't rely on it. So yeah, and for more information, we also have a blog post where we go through GitLab CI/CD caching. The next keyword I would like to give a highlight or to highlight also is the allowing job failure keyword. We can use the allow failure keyword with a value of true on a job, so that when it fails, the pipeline will still carry on. For example, you can allow the code quality or unit test to fail, and the pipeline will still pass. And this is what we can see also on the right screenshot here. We have 3 stages, the build, test, and deploy stage. And we have 2 jobs in the test stage, test A and test B. And we set up that test B is allowed to failure. And that the pipeline will still pass once the job is failed. Next keyword, well, we are talking about rules. So you can use rules to include or exclude jobs in pipelines. Rules are evaluated when the pipeline is created and evaluated in order until the first match. So when a match is found, the pipeline is either included or excluded from the pipeline, depending on the configuration. And rules accept an array of rules defined with what you see here on the screen, and you can combine keywords to create more complex rules as well. So we have clauses like the if the changes exist or the none clause. We have operators, equal, not equal, and or. We also have job attributes, when, allow failure, start in, and we have options, always, never, on success, on failure, manual or delayed. And yeah, let's move to some examples. On the right, we have a prodigal example of a job with rules. The script check section defines the job's logic. In this case, it simply outputs hello rules. And the rule sections defines conditions that determine whenever the job is included. We have 3 different rules. The first rule checks if the CI pipeline source equals the merge request event. If this evaluates to true, then the when clause will execute it and ensures that the job will not run. Similarly, the second rule applies to pipelines triggered by scheduled. So if CI pipeline source equals schedule, and it also executes the job with when never and ensures that the job will not run. And the final rule allows the job to run on success, which means it executes if earlier jobs in the pipelines succeeded. And with that, we also see this example 2 slides before. Let's talk about how we can configure for manual execution. Manual execution allows us to have even finer control over when specific actions take place in your CI/CD pipeline. You can decide when you would like to deploy something. Instead, it will deploy automatically. It will wait for someone with the appropriate permission to manually trigger it by clicking the play button in the UI. And this is particularly useful for sensitive stages like deployments, where you might want to validate everything before taking action. For example, if you would like to deploy a new REST API on the production environment, then you can do this manually and doing maybe in the night when no one is using the API, so then you don't have any interruptions. And the only thing you have to do is go to your job and use the when manual keyword. What if we want to delay a job run? So this is exactly what we can do with the start in keyword. In the example on the screen, these jobs will be created only when the pipeline is merging into our default branch. In this example, it's our master branch. And what we can see here, it will start delayed in 3 hours, and it's allowed to fail. And the timer on the delayed job starts ticking immediately after the previous stage has completed. And with that, lastly, before we go then into our first lab challenge, this is an overview, or this overview is really quite useful to help to understand the order of variable precedence from highest to lowest. At the very top, we have our CI/CD variables. These are the ones you set when triggering a pipeline manually or through an API call, and these take absolute precedence over everything else. Moving down the hierarchy, we have a project, group, and instance level variables, which provide consistent values across the different scopes. Then we have the inherit variables from previous pipeline stages, variables defined directly in YAML files, and finally, the predefined GitLab environment variables. And this order is really important because if the same variables are defined at multiple levels, the one with higher precedence wins. For example, a variable defined at the project level will override the same variable defined in your YAML file. And all these variables ultimately feed into your CI jobs that run on the GitLab runner. And with that, let's move to our first lab, or our second lab. So after we set up everything for the lab environment, please go to your group where you will find also the Tanuki Racing CI to Primo workshop. When you go into this project, we see a lot of resources there. Most of the projects, I think, are written in Ruby. And we also have a folder, it's called courses and workshops. And there we will find CE to Premium folder. And in this folder, we see the different tasks and labs we are doing in the next minutes. So let's open the task, and then we can go step by step through the different sections. All right, maybe I will give you some seconds to find the right lab, and then we can go through this.
Johannes, the issues are already imported in the issues. So if you click on issues, you can see the 4 issues there.
Thank you. Good. Perfect. Here we can also see the issues with the description and also the steps we will do in the next minutes. So thanks, Seraphine.
You're welcome.
With that, let's do our first task for this, our first step for this first lab. So yeah, what we are doing is we creating a simple pipeline. So let's move to our GitLab CI YAML file. In general, we have different options how to edit the file. So what you can use, you can go to our web IDE editor and also yeah, editing the GitLab CI YAML file via the add web IDE editor. You can also yeah, check out the project and then working on your environment. But what we are doing is we go to our build and our pipeline editor, and there we can also adjust our GitLab CI file. And yeah, the first step is to replace the entire content with the content we have on step 1 and on the second point. So I will only replace the entire content. And yeah, let's have a look on these GitLab CI YAML file. So what we have a lot of variables defined, like the CS default branch image, the Docker driver, Docker TLS scripter. We also define 2 stages, the build and the test stage. And in these stages, we have one job, it's called build job, and one job, it's called the test job. And we also have in the build job the before script keyword, the script keyword, and the after script keyword. And in the test stage, we also have defined some rules. What we do like next is that we add the after script keyword to our test job, and this is step 4. So let's go to our test job. We have here our script statement, and then the only thing we have to do is paste our after script keyword. And yeah, please have in mind to have the right spaces there, so everything works as expected. And what does the after script keyword do? So it also just generates an output. Our racetrack has been tested. This is how our new test job should look like. We don't commit yet because we are directly going to our step 2 and adjust the execution order. So with that, I already told that we need the needs keyword, and what we are doing is we create a new job in the test stage. It's called a super fast test job, and it's already include a needs keyword, an empty needs keyword, which means yeah, this job will run asynchronously when the pipeline triggers when the pipeline is triggered and the build job is done, and then when the test jobs will be executed. So yeah, let's paste it there. We have a super fast test job in the test stage, and we have a script which return if you are not first, you are the last. And we also return 0, which means we want that the test will fail. And we have our needs keyword, which includes nothing, so that it means when the test stage will be executed, then both jobs, the test job and the super fast test job, are running, executed in parallel. I will wait a couple of seconds that everyone is able to yeah, do the same. But as I said, we don't commit yet because we are adding rules and adjusting for failure. in the next step. And once we have done with all of these sections, then we will commit and go to the pipelines and see what happens. Let's wait. And if you have any questions, please use the Q&A section. Sarah and Serafina are happy to answer everything. All right. Then let's move forward to step 3. We now would like to adjust the already existing rules. So what we look like to do is to only run the job when it's our default job. And yeah, let's adjust our if statement. So if yeah, we need our CI commit branch and is our CI default branch. And with that, that means the job only will run when our commit branch is our default branch. So whenever you commit something to, in this case, to the default branch, in this case, I think it's our master branch, then this, yeah, this if statement will be executed. And let's move forward to the next one. We also would like to allow the super fast job to fail. In this case, something wrong. So in this case, the job runs through, and we would like to run to fail. So we also added the exist one. So this means to make the job as failed. And we also would like to add some rules to the super fast test job to allow failure jobs. And with that, we need to add some rules. We created a new rule if CI commit branch equals CI default branch allows failure to true, and we do not commit because we have a one last step before we commit, and then we will have a look into the pipeline. Maybe let's wait a couple of seconds. So everyone also did the adjustments. And the last thing we would like to do in step 4 is to improve our pipeline speed by using cache. So we would like to add in cache to the vendor Ruby and Gemfile log. and so they don't have to pull it in every time. And yeah, what we are doing is we creating a new cache after our image keyword. So what we are doing, we created a cache, we defined a key, we also defined some fallbacks, and what we would like to caching is the render Ruby folder and the gem file log. And yeah, once we added caches, our file should looks like this. To make sure that I did everything right, I also will copy paste the file which in the issues itself to make sure that I didn't do something, didn't typo, and everything runs as expected. So maybe let's have a look final to the GitLab CI YAML file. We have our image. We use the Docker latest image. We created our cache with a key and also fallback keys and paths. We have a Docker and Docker services. We have different variables. In general, we have two stages, the build and the test stage. In the build stage, we have a job, it's called build, which includes the before script, our script, and the after script. And we have a test stage with the test job, which also includes a script statement. We have rules for the test job, and we have after script. And we have a third job also in the test stage. It's called super fast test. We do in the script statement, we do an exit with 1. It means this jobs will failure. To make sure that both jobs, the test and the super fast test job runs in parallel, we added the needs keyword, and also we do define rules. And if we commit into our default branch, we allow a failure true. And with that, let's commit everything. In the issue, there's also a message for the commit message you can copy and paste. So optimize CI pipelines by adding caching for Ruby, GEMS modules, allow jobs to failure, and enable parallel execution. We commit the changes directly into our main branch. So let's commit. Yeah, we get the message that we successfully committed everything. And now, checking the pipeline status, we see that a new pipeline is triggered. You can also, and you have two options. You can go directly to via clicking on this pipeline, but you can also have, so when I go there into the pipeline, you can also go to build pipeline, see different pipelines. And what we see, we have two stages, build and test. The build stage is also running, and also the super fast test is running. And when you go to the job dependencies, you see that we don't have dependencies, so can also run dependencies. And build and super fast test jobs are running in parallel, and then we have the test job. And there is a warning on the super fast test job because we said it runs in an x equal 1, and the error is the job failed, but this is what we allowed. And let's have a look to the build job. Maybe I can also open the pipeline editor in parallel to compare everything. So there's the before script where we'll run with Docker info and Docker login. And when we go to the job itself, then we see, okay, here's our Docker info statement where we say something about the info. And then we have our Docker logging statement, and then we have our Docker build. but this was executed in our script statement. Okay. And then we have the after script Docker push image. So maybe this takes some time, but here we see our Docker push image and we see the job succeeded. Let's refresh. Then our test job is now running. And what we should get here, we see some shell commands. We also have some rules, and what we also should see is our output. So this also takes some seconds. So let's wait until the job is succeeded, that I can show you that the after scripts also will be executed. So now we see our before script statement where we run our shell commands, and then we also should see our output. Our racetrack has been tested. Now we can see that our after script is running, our Azure prompt, and then we see our output. Our racetrack has been tested. And with that, let's go back to the issues. We did everything regarding the first starting pipeline task with the 4 different steps. And what we can also do is we can now close this issue if we want. So we can close it. And with that, back to you, Claire. But I think we are doing some short break.
Why don't we run one of the poll questions asking where people are in their DevOps journey?
Yeah, that's great. So you should see a poll where you on your DevOps journey, and no. Thanks for all the answers.
Johannes, could I share my screen now?
Yeah, sure. Let me stop my screen sharing. So I'll be able to share a screen. And
Seems
thanks for
like
all the answers.
Seems like most people have answered. Thanks for letting us know. It's cool to see we have a big spread here. That's exciting. Okay, let me share my screen. Okay, can you see my whole desktop window?
Yes.
Awesome. Thank you. Okay, just so everyone knows, I am getting over a cold, so if I randomly go off camera and go on mute, it's not that I've abandoned everyone. I'm just coughing really briefly and don't want to subject you guys to that. So at this point, we are on to lab 2. You should have a pipeline running with execution order, allowing for job failure and artifact caching. If you're still behind, feel free to ask in the chat as you'll have access to this workshop for the next 2 days to finish up. On this lap of our Tanuki racing game, let's look at code owners, approval rules, and merge request pipelines. So this is where we are currently in the agenda. After demonstrating your simple pipeline to the team, they were impressed and asked if you could enhance it by implementing code control, further speeding up job execution, and adding a mechanism to ensure the default branch always remains stable and green. You decide you are going to show off your skills and show how you can add code owners, approval rules, and caching to your pipelines. So let's get a brief overview of those features before we actually implement them. Code owners is really handy when you need to set out domain experts for given areas of your project. So this lets you assign team members responsible for specific domains of your project. And it's also worth noting that code owners can be automatically assigned as merge request approvers for merge requests pertaining to their specific area of expertise. Merged results pipelines are a special kind of pipeline that run on the results of the source and target branches merged together. So it merges your changes with the default branch to detect any errors or changes that may be green on your merge branch, but break on the default branch before you do a merge. You will see this shortly in the hands-on section as well as code owners. Approval rules ensure that the right people are reviewing merge requests. You can specify how many approvals a merge request should receive before merging. This can be used in conjunction with code owners to ensure that changes are reviewed both by the group maintaining the feature and then also specific either project-wide approvals you need to do for other departments, so they can serve slightly different purposes there. And any groups responsible for specific areas of oversight. So maybe you have a licensed team that always needs to look over all your merge requests. So now we're going to move on to the hands-on workshop. So you can access this from within the C to Premium Workshops MD file, but you can also access this from the issues in your project itself. I'm going to go ahead and do a split screen. Come on, get the split screen working. There we go. So that you can see both what I'm doing and then also the instructions. Can everyone see both of these still? Johannes, if you could give me a thumbs up.
Yeah, we can see it. Thanks.
Cool, thanks. Okay, so we're going to go back to the pipeline that we had in the first track, and we're going to add additional rules and stuff. So first thing we're going to do is we're going to set our approval rules. So we're going to go to Settings, Merge Requests, Merge Request Approvals, which are here, and then Approval Rules. We're then going to add an approval rule, and we're going to call it DevOps Checks. We'll set all branches as the target, and we're going to require one approval from a user called LF Stucker, who is a demo architect at GitLab. And he's not actually going to be interacting with any of your merge requests. This is just to demonstrate how this feature could work. And we can go ahead and click Save Changes. Now that we've configured this approval rule, we're going to configure code owners, and then we're going to watch both of them take effect. Okay, so code owners is the file that we need to define to actually set the specific domain expertise areas. The first thing we're going to do is we're going to go to our code repository, and then we're going to edit from the web IDE. So our web IDE is pretty cool. It's a VS Code implementation. And as a VS Code user, I really like it for making quick little edits and stuff. It's nice to have the UI stay the same. So we've gone into the web IDE, and now we're going to create a new file called code owners at the root repository. level. Then once you've done that, you can go ahead and add this block of code. And basically what this is saying is our infrastructure team is responsible for the README file, and that team includes LF Stucker. So anytime someone's making changes to this file, he is going to get tagged, or he's going to get included in the merge request. Okay, so now what we're going to do is we're going to click on the source control button, and I want to make a note here that we're going to push to main from here, but later in the lab, we are going to be pushing to different branches and creating different branches. So know that in the future, you're going to be clicking this button. Right now, I think is the only time that from the web IDE, we're going to be pushing directly to main. And let me just double check that because I fear it. Yep, we're good. Okay. So that pushes to main. Now we're going to go and make a change to the README file. We're already in the web IDE, so we can go to readme.md, and I'll just add this at the top. So because we referenced readme.md within our code owners, this is now going to add Logan when I make a merge request here. So this is going to differ from the last time we just did this. We're going to commit and push to a new branch. So let's add the commit message. And then instead of committing and pushing to main, you're going to click this arrow, create a new branch. Oh, wait, they want us to click push to main here. Okay, never mind. Don't listen to me yet. Okay, actually, never mind. Listen to what I was saying. I got confused with the very thing where it says push to main here, but we are going to another branch. So you're going to click create new branch and commit, and then you can just press enter, which will automatically create a name for your branch. We can then click create merge request here. And then once we're on this, we can uncheck delete source branch when merge request is accepted, because you might want to come back here and look at the changes you made to code owners, for instance. So, so then we're going to create the merge request. And once we are on the merge request page, we can see that it is blocked because of the approvals from DevOps check that are required. You'll notice that the code owner's protection rule is optional, and there are two reasons for that. One is that we haven't enforced code owner's approval, but the other is that you are an owner of this group. So I believe that code owners will always be optional for specifically you in this lab because you are an owner. So it's still good to demonstrate how one would do this. We're going to go to we're going to go to settings, repository, protected branches. Oh, here we are. And then we're going to toggle on code owner approval and enforce it. And you don't actually have to click save or anything. This automatically saves it, I believe, when you click the toggle. And now we are going to go back to that open merge request that we have. So you can click on merge requests, and it's probably the only one you have in there. Now when we look at this, there won't, oh, it is required, or yeah, so now it is requiring it. Cool. I thought for some reason that if you're an owner, it doesn't get required, but that's actually good that it's enforcing it. Sorry, Seraphine.
Yeah, just want to add, at first, it gives you optional, so it doesn't enforce it. And then when you went to setting and toggle it on, then it enforces it.
Yeah, I thought previously, if you were an owner, you could override that, but it sounds like either that's changed or I had a misunderstanding before. So thanks for clarifying that. Cool. Okay, so now that we're on here, we can see that this has been enabled, but because we don't want to have Logan have to approve every single merge request in this group that we've all just made, we're going to go back and toggle it off now that we've seen how it works. So we'll go back to settings, repository, then back to protected branches, and just toggle this off. We're going to leave the merge request open and proceed to the next step, but you can always go back to it and check it out again if you'd like to.
You also have to remove the approvals as well, or else it won't let us move forward.
Oh, sorry. Yep, my bad. So we're also going to remove the approval rules. Thank you very much, Seraphine. So if we go to settings, merge requests, and then to merge request approvals, we can go ahead and click the bin icon and say, bye-bye, Logan. He's not going to be here anymore. Cool. So now that we've done all that, that automatically saves the changes when we click the bin icon. We can go ahead and leave this merge request open still, and let's move on to step 3. So we're now going to talk about merged results pipelines like I showed you in the slides. So we're going to go to build pipeline editor for this. And we can add these workflow keywords right under stages. So the cool thing about the workflow keyword is you can apply rules to specific jobs, but you can also apply rules through this workflow keyword to an entire pipeline. To speed up the pipeline builds, let's go ahead and remove the super fast test job, since we got what we needed to from him. And at this point, your GitLab CI file should look like this example. So with the removed super fast test job and with the workflow rules added here. These workflow rules specify that this pipeline is going to be executed as a merge request event pipeline. Okay, and now we are going to commit let's add this as a commit message, enable merge results pipeline. And we know that we are going on to main, and let's commit these changes. Okay, so now we are gonna go back and do another merge request test. Let's go to code repository and then web IDE. And the reason I'm making changes to my GitLab CI file here in the web IDE versus in the pipeline editor is the pipeline editor is generally for making changes to already existing branches. And you can't automatically create a new branch from the pipeline editor. So we do that here. So we are going to go ahead and add this line to the after script section of our build job. So if I go here and add to the after script, I want to make sure it's at the right tab level. And the build job should now look like this, which it does, thank God. Okay. Now we are going to do the same thing we did earlier, where we're going to create a new branch by clicking the down arrow and create a new branch and commit. And then just hit enter to get it to automatically create a branch name. And we can create this merge request here. We can just go ahead and create this. You can get rid of deleting source branch when merged if you want. If you want to look back at things later. And you should see here that we have a merged result or merge request pipeline. Should be a merge result pipeline. Should it not? Seraphine, is that supposed to be merge result rather than merge request pipeline?
Yes, it's supposed to be a merge. Well, one second, I went to grab tea. Let me just have a look.
Let me double check that my or what am I doing? Sorry. I want to go to pipeline editor. So it's got that in there. So we'll look behind the scenes into why that's happening. For other people, are they getting a merge results pipeline status there, or are they also getting a merge request pipeline? The difference being, remember, we talked about the merge results pipeline being the combination of your default branch and the branch you are merging from, versus a merge request pipeline is just running on the branch you're merging from, and in where a merge request exists. I had encountered this before when I was looking through, and I think what can work for me is that I just tried it again. So let's try going to code repository and web IDE. Let's try again. Yeah, it's still running a merge
Are
request.
you are you on a branch? Let me just look at the content. Are you supposed to be on a branch there?
Yeah,
So
I
it
am on
depends. If you're on an emerald, you might have to be on. Did you merge the workflow keyword into the main first and then you created a branch?
Yeah. All right, guys, we're gonna do a little bit of live documentation looking at.
Yeah. Let me have a look.
Let me double check I did this. I'm not sure I did this step. Maybe I'm crazy.
Oh,
Folks.
let's check.
Yeah. Settings, merge requests.
Yep. I think you need to toggle it on.
Okay, so I apologize for that, everyone. That is super my bad. I think I must have missed the step. Yeah, I missed this step. And I'm sorry about that, guys. I'm a little bit sick. Please forgive me. And now
It
let's move on.
happens. This one makes it fun.
Yes. Okay, cool. Well, I'm glad we got through that. And let's go ahead and just do this again. So if we go to Web IDE and we add to our after script one more time. Then we can go ahead and not push to main. We're going to create a new branch and commit Claire. And then create the MR. Beautiful. All right, so if you got a little lost in that section, I'm just going to quickly go over it again. So when we are enabling the merge results pipeline, the first thing we have to do is go into the settings to actually enable this type of pipeline to happen. So you go to settings, merge requests, merge options, and then enable merged results pipelines. Okay, and then after that, you go in and add the workflow rules and make your merge request. Cool. Now, where were we here? So we created the merge request. We see the merge result pipeline is running. And once the build is complete, we can go ahead and click on merge. We can also see what type of pipeline is running from the general pipelines page. So if we go to build pipelines, where we have a list of the pipelines we've ran in this project, you can see that we have a merged results tag here. And then also, because those last ones, we didn't have merge request or merge results pipelines enabled, they ran as merge request pipelines. Okay. Yeah. So a little exercise we have at the end is that only the build job is available, is being triggered here. And I'm very curious if you guys can think about why that might be happening given our pipeline definition. A little hint is the rules for the test job. And let's take a little break here. I guess since we can't like discuss it in this webinar, I'll share the answer here, which is that these rules define that this job should only run when the branch that is being committed to trigger the pipeline is the default branch. So because we ran this on a merge request, it is not a default branch pipeline, and the test job does not run. Okay. So that's the end of this section. We can go back to full screen here. Or I guess I should show you it merged. Let's close some tabs too. We got a little crazy with it. So if I go to my pile of merge requests here, the most recent one should be the one we want. And because this merge result pipeline has passed, we can go ahead and click merge. You might have seen before there was also an option that I could have clicked called auto merge, which basically once it passes the pipeline successfully, it will merge for me. So you don't have to sit around if you have like a really long pipeline that runs. Okay, so I think we should take a little 5-minute break here. And if we could also put the poll that asks how the pace is going up, that would be really great. So yeah, I'll see you all in like 4 to 5 minutes, okay? Cool. Hello, everyone. Okay, so I think we've had like a 3.5 minute break. I'll start slowly back in case people are still getting their coffee. Um, I got myself a cough drop, so we're all doing very well. And the poll. It seems like we are either just right on pace or too fast. The small majority who voted too slow, I'm sorry, you have been outvoted. So just sit tight. And let's move on to our next slide. So in lap 3, we're going to be talking primarily about merge trains. So we are pipeline superstars at this point. That is incredible news. As you present your new pipeline to the team, they mention experiencing issues with conflicting changes in merge requests when merging to the default branch because of frequent merges. You know GitLab can resolve this by queuing merge requests and comparing each one against earlier requests to ensure compatibility before merging. As a superstar, you set out to implement this solution. Yeah, merge trains are a really exciting feature in GitLab, especially for large repositories where you have a bunch of people with different branches committing at once. It's one of those features where life is a lot harder without it, and once you have it, you really don't want to go back. Oh, and I haven't been sharing my, I am sharing my screen. Okay, sorry. It's sharing correctly, right, everyone? Yeah, cool. We're good. Actually, never stopped sharing. I don't know why I said that. Okay. So merge trains introduce a way to order the flow of changes into your default branch. In fast-paced environments where frequent changes to default branches can lead to issues, while one merge is being validated, another is merged into the main branch. So the subsequent merge could render the previous validation invalid. Merge trains create a queue of merge requests so that multiple developers are able to collaborate while keeping the default branch green. Each queued merge request takes the completed state of the previous merge and adds its own changes, and then runs a pipeline in its respective branch before it's merged to ensure they all work together. So merge trains, merge requests, and merge results pipelines are all fairly similar concepts. To enable merge trains, we need all 3 of these features to be enabled and working. In the previous track, we looked at merged results pipelines and also merge request pipelines accidentally. But I thought it would be a good addition to compare these in a slide, as it can be kind of confusing. So at a high level, merge trains, merge requests are put in a queue and run on the changes of the previous merge requests ahead of the queue combined with the target branch. A merge request pipeline run on the contents of the source branch only, ignoring the contents of the target branch, and are simply triggered when a merge request is present versus a branch existing with commits to it, but no merge request. And then a merge results pipeline runs on the results of the source and target branches merged together. We're now going to go ahead and look at the workshop instructions for this. So let me swoop my little screen. And then I'm gonna, oh, what have I done? I'm gonna look at these through the issues section again. So now I want to go to merge trains, number 3. And in this, we will be adding a CI/CD feature called merge trains that we just discussed. The first step of this is we're going to be going back to build pipeline editor. So if we go to pipeline editor here, we are going to add the below code to the workflow configuration. So your final workflow should look like this that I'm showing here. And remember, this workflow keyword acts on all of the jobs in your pipeline. So we're saying that we want this to affect the entire pipeline as opposed to just a single job. So our GitLab CI YAML file should now look like this. If you're worried you've gotten lost, I would recommend just copy and pasting this and putting it into your CI file. 1 second. Okay, I'm back. Sorry about that. Okay, so we're going to add a commit message of configuring merge request pipelines. And then we're going to go ahead and check that the branch is on main. Yes. And commit our changes. So while this runs, let's, sorry. Sorry about that, folks. One of the nice things about working from home is that I can still participate in stuff without worry of infecting everyone. It's just a bit of a cough. So while this runs, let's go ahead and enable merge trains. So if we go to the left sidebar and we go to settings, merge requests, merge options, just below this setting that gave me so much trouble earlier, the enabling merged requests, we want to go ahead and enable merge trains. We then scroll down and we click Save Changes. So to test this, we're actually going to need to create 2 separate merge requests. So let's go to repository so that we can open our web IDE. Go to Edit, Web IDE. And now what we're going to do is we're going to create a new file called firstchange.md. It doesn't really matter where you put this because we're just trying to create 2 different merge requests. Once you added, so then let's go ahead and create our merge request. So we create a new branch and commit, press enter to get the automatically assigned name, and then create a merge request. On this page, we can leave all as is and create merge request. And now let's go back to the web IDE, go back to the main branch, and we're going to go ahead and create another file called secondchange.md. Like the first one, it doesn't matter where we put this. We want to then go ahead and commit this to a new branch. Press enter and create the MR again. Leave all as is on the creation page. Click create merge request. And then if we look on this, you should have 3 merge requests. I have 5. You might have 5 too, because I did leave you astray for a little bit, but you should have some amount of merge requests, 2 of which are these. We have these 2 merge requests in second tabs, or in 2 tabs. And these requests should have that. So now we can click set to auto merge for both of them. And you can see that this is set to run after the first change that I triggered, and it's in a merge train that will kick off after this one goes. So set to auto merge on the first request. Yes, we've done that. After the pipeline build passes on your first merge request, the merge train is kicked off immediately with a display saying a new merge train has started, and this merge request is the first of the queue. Sounds like the wording has changed slightly, but yes, that's what we've got going on.
Okay.
Do you agree, Seraphine?
Yes, it will show as soon as the pipeline passes. So
Oh,
the build has to finish, yeah. I think the first one, I don't know which one was kicked off first.
I kicked off this one first, just to keep it confusing. Um,
Love it.
cool. So yeah, again, this is a very cool feature. It can really save a ton of headaches when you have a bunch of people contributing to like a really large monorepo and stuff like that. And yeah, once both merge requests have been successfully merged, you can verify the changes by checking that both second change and first change.md are added to the main branch. So we have successfully completed this stage of the lab.
Now, Claire, you can now see it there. So if you click on the merge train details on your just up underneath the merge train, yeah.
Oh, view merge train details. Here we go. Yeah.
Yeah, you
Okay.
can then see it being lined up.
Cool. So then, yeah. And presumably, like this merge train might get much more complex in an actual production setting. So it can be very helpful to see all of them here. Okay. So now that we've completed this section, we are on to lap 4, which is actually the final lap. Let's do like a 2-minute really quick break and run another one of those poll questions. I can't remember which ones we have left, but Helen, I bet you'll pick a good one. Oh yeah, that's a good one. So we'll take a really quick break. I'll be back in 2 minutes, so 10:35. And everyone, please answer this question, and we are on to the final stretch. Okay, everyone. Thank you all for answering this question. We're gonna start again soon. And we're gonna move on to, first off, let me clean up again. Let me clean up again. And we'll go to the slides. We're now at the reusability and security section of the learning. And in lap 4, our manager is exceedingly impressed. We are not going to get pipped this year. After implementing merge trains, your pipeline is running smoothly again, and word has reached the executive team. Wow, that's good news. They want to ensure that all of GitLab features, such as components, security scanning, and artifacts, are being fully utilized for purpose, speed, and faster time to market. They've asked if you can demonstrate these features in a pipeline during the next stand-up meeting. You are thrilled to take on this task because this marks the beginning of adopting best practices such as shifting security left and centralizing workflows across the company. So the first aspect of this is going to be using GitLab's CI/CD components. These are very similar to our CI/CD templates, which you might have used before, which allows you to import CI/CD configurations not stored in your default GitLab CI YAML file. And CI/CD components are very similar to this, but they have a couple key advantages. To call out a few, they can be configured with input parameters for more dynamic behavior. They can be released as a true app with versioning. So you could specify a specific version of the component, and they can also be listed within the GitLab's CI/CD catalog, which I'm going to show you in the next couple slides. Some examples of existing components that we have are, our OpenTofu one, any of our GitLab maintained security scanner ones, and then some other community ones as well. You can see there's little badges that show when something is maintained by GitLab or a partner that's verified. If this is the first time you are hearing about the CI/CD catalog, basically it's a list of projects with published CI/CD components that you can use to extend your CI/CD workflow. And many of these are actively maintained by the GitLab team. You could compare this somewhat to GitHub's Actions catalog, I think is what it's called. Components really come in handy when migrating workloads. You can set them to private so that you can use them internally and don't have to publish them in the GitLab CI/CD catalog, or you can publish them if you want to share with the wider community. You can build a larger component or a larger pipeline based on many components. This is a really great thing to think about if you are trying to templatize your workflows. As much as you can get your pipeline standardized across all of your projects, it will pay off in the future in terms of workload and building out new things. So template support, just because we talked about components, now let's talk about the other one. Templates are a way to share CI/CD capabilities similar to components within your organization. The same as components, you use the include keyword to add these to your YAML file, and we're going to be showing you this in the next practical section. There are 4 different types of ways you can include external CI/CD files. One is with a template, as we see there. One is referencing a local file within your organization. The local is for files in your same project repository. Files are for things in the same group hierarchy, and then remote is a YAML located in a publicly available repository elsewhere, so perhaps provided by another company or community. Options for customizing job behaviors. There are a variety of ways that we can customize the behavior of the jobs in our pipeline. It's extremely flexible. We can override the default behavior of a template job by specifying keywords in a local job. So this would keep most of the job the same, but use any values set specifically in the job in the local file. Part of the reason I bring this up is so that you understand how we use templates, where you can override specific aspects of a template, but also to highlight the usefulness of components, which have these injectable variables that make it easier to, it's a lower barrier of entry for someone to be able to think about how they could customize that. Pipeline security. So best practices is to mask and protect your CI variables for low-risk secrets. For high-risk secrets, you need to use an external tool like Vault. GitLab, I believe, is looking into, over time, creating our own secrets repository, but at this time, we recommend for high-risk secrets that you use Vault or a similar external tool. How to configure SAST scanners within GitLab. So this is how you would add a SAST scanner manually in your GitLab CI/CD file. If you've been paying attention, you may have noticed that you have access to view new findings in the merge request widget, see merge request changes, and more. This is because an ultimate group was provisioned for you specifically for this workshop. I know that we're talking about CE to premium, but it's easier for us to just provision ultimate. And you're in an ultimate group right now. And we do this so you can explore the full capabilities. In our simple pipeline for build and unit test, we have already used the artifacts keyword to store directly containing the build results. Expiry is set to what the job file specifies. In our file, we have set the artifact to expire in 1 hour. If you click keep within that timeline, you can go back later and store them manually after it was supposed to expire. Even though GitLab has a registry built in, you can also send it to artifact registries like Harbor or Artifactory if you want. If we don't set an expiration time for our job, the GitLab instance level default value will be used. And on gitlab.com, that default is 30 days. And there's one other thing to be aware of, which is you must have the appropriate permissions to view and download artifacts. For public projects, any user with guest permissions or greater can view and download them. And for private projects, you need reporter permissions or greater. Let's discuss artifacts before we jump into the next portion of the lab. Sometimes you want to be able to download the artifacts related to a job. You have 4 different methods of doing so. You can do it on the pipelines page, on the jobs page, on a specific job, or in the artifact browser for a job. And now let's go ahead and start that 4th section of the workshop. Cool. So let's go ahead and open our last issue, which is going to be issue number 4, reusability and security, the most fun one, in my opinion. Oh, didn't mean to do that. So the first thing we need to do is we need to go back to our pipeline editor because we're going to be making some changes to main. So if you go to build pipeline editor, we can see our YAML file. And then under where we defined our image, so right at the top, but it doesn't really matter where we put these, we can include some templates and components. So what we're doing here is we are including our dependency scanning job as a template, our GitLab SAST scanning job as a component, and our secret detection job as a template. And let's take a closer look at these things we've added. If you click this little tree diagram here, you can actually find out more about the templates you've just added. So here we're looking at our dependency scanning template. And if you remember when I was talking about how you can overwrite aspects of a template by referencing it in your main GitLab file, if you were wanting to overwrite this, you could say, let's say, for instance, we know that they want to run dependency scanning in the test stage, but we want to run it in the security stage. We could reference the dependency scanning job in our .gitlab CI YAML file, and then say this test is security, and also include a security test stage. And that would overwrite the template configuration. What we're going to show you soon is that with components, rather than having to do that, you could just inject your new value of the stage, which we are going to show you in a second. So yeah, we looked at the expanded, the tree thing. We opened a link to see, and we can also generate a full configuration that includes all of the templates if it's easier for you to look at everything together. It's probably not easier for you to look at everything together, but just in case you want to. And then we can go back to edit. The pipeline editor is a really great tool. You can also use It's visualizability, which can show you what your pipeline is going to look like. And then the validate section, which will simulate a pipeline run and can really help you with a lot of those small little like kind of silly errors you may get that prevents your pipeline from running. And you don't want to be embarrassed showing everyone your failed pipeline when you make those small little errors. Okay. So we clicked on the links, we looked at the full configuration. But before we commit, we are going to add inheritance to the next step. So let's add a new input for our SAST component. This component right here on line 5. If I replace that and add an input, this is kind of talking about those injection variables that mean we don't have to reference the component within this file to make changes. Now what's happening is we are telling the component file to run GitLab Advanced SAST, which is our new SAST scanner. It's very cool in my opinion. What it can do is it can run cross-file and cross-function taint analysis, which essentially reduces your number of false positives by verifying whether or not a given block of code will ever actually be triggered in your current configuration. It's very cool. It's definitely something to consider if within your current scanning configuration, you're facing a lot of false positives and having to spend a good amount of time triaging those. Okay, sorry, spiel over. So yeah, your include section should now look like mine here. And before we commit the code, let's see how we could reuse some parts of our code in other projects with the help of components. So we talked a bit about CI/CD components before. These offer reusable pipeline configurations. And in this case, what we're actually going to do is rather than having our build and test jobs directly in this file, we're going to import them with a component, which also draws back to that templatization of your pipelines that I was talking about. If you have a central build and test component that works for all of your different projects or a large majority of them, you've reduced a lot of the maintenance work of maintaining those pipelines. Okay. So we are gonna first check out the pipeline editor. If we go, or not the pipeline editor, we're gonna check out the CI/CD catalog within GitLab. And you can see that there's a number of community contributions as well as contributions from GitLab or from our partners. And yeah, you can have a quick look through, see if any of these existing components might work for your existing workflows. Yeah, it's cool stuff. So we've actually already created a CE to Premium component project for this workshop, which we can look at here. And it stores these YAML configurations here. And we are going, and yeah, notice that this has both a build and test, and then also a security check job, which I know it's just an Echo script right now, but this would in theory maybe trigger some of your external security checks or trigger some GitLab scanners as well. Okay, so to use this component, we are going to add this to our include list. There we go. Add it to our include list. And your include list should now look something like this, but not with this tab. It should actually look exactly like this here. So if you copy this whole section, just make sure you remove that tab in there. At this point, because we are using a component build and test job, we can remove these from our file because they're already being brought in from the component. And let's also add security to our stages because you remember when we look at this bad boy, we see that this runs in the stage security. So we have to provide that stage for the pipeline or it's going to be confused. So I scroll around everywhere and then I'm gonna add security. Okay, we added security. And now your final GitLab CI YAML file should look like this. If you got lost at all during this and you feel like your file might have diverged from mine, I would highly recommend just copy and pasting this into your CI file so that you can see what the final result should be. Now let's add our commit message to describe what we've added to the pipeline and go ahead and commit the changes to main. So now if we navigate to build pipelines to see our full list of pipelines, we can see that we have added the build component job, the test component job, and the security component job, as well as our dependency, advanced SAST scanner, and secret detection. You'll notice that semgrep SAST is also running, and this is because GitLab Advanced SAST has a slightly reduced number of languages that it works on at this time. We're building it out, but we're starting with the most popular languages first. So what happens is our SAST analyzer checks which languages are present in the repository, and if you've enabled Advanced SAST, but you have languages present that aren't covered by Advanced SAST, our semgrep scanner will run for those non-covered languages. Cool. So then the last little bit for this is the bonus exercise. And notice that the names of our jobs here are build component job, test component job, and security component job, even though that's not necessarily the names here. The reason that happens is because if we go back to pipeline editor, we can see our inputs here were build component, test component, and security component. And the names of this component for the jobs is created by whatever the inputs are for build job, which we've done here, plus dash job, which is exactly what the output of our job names was. Okay, that is it for the written content, but we have some more stuff to go through, which is, first of all, if you would like to transfer your project to a separate namespace so that you can keep looking at it after a couple days, I'm going to go through the instructions for that right now. So only transfer this project once you are done because you don't necessarily have an ultimate license on your other namespace. Many of the capabilities that we go over in this require you to have some form of paid license. So if you are on a CE license, you might not necessarily be able to access some of these features. There are instructions for how to do this if you go to courses, transfer project, and then transfer.md. And in conclusion, GitLab Premium provides really easy solutions for faster code review to ensure higher code quality across teams. Our advanced CI/CD allows you to build, maintain, deploy, and monitor complex pipelines, as well as facilitating a large amount of templatization of those pipelines. And Enterprise Agile Delivery helps you plan and manage your projects, programs, and products with integrated Agile support. We are going to have a Q&A, but first, I would really, really, really appreciate it if people could fill out the survey that we have here. Oh, briefly going back to the project transferring, you have 2 days to play around in this ultimate group before you will lose access. So we're not saying you need to transfer right away by any means, but if you would like to save it after those 2 days, we would recommend doing a transfer. Back to this QR. It would be extremely helpful to us if you guys can fill this out. I know it's sometimes annoying to fill out things like this, but we really like delivering these to our customers, and we really want to make sure the content is what you want. So it really helps us. And yeah, I'll be very sad if no one responds. Any Q&A at this time? I can look at the Q&A here. Looks like people are having some trouble accessing the Google form, maybe. I need to remove period after edit. Oh, I see. There was a period there. Okay. Yeah, if anyone has any questions about the content, I know you've been doing sort of a live Q&A the whole time, but I can answer some of these verbally if people have questions now. But really what you should be doing is filling out the QR form survey first off. Okay, I'm gonna go off camera and audio unless I see any more questions. We're gonna keep this up for a little bit.
There's some
Yeah.
questions on the Q&A chat. I
Sorry,
can read them out. Okay.
What are the ultimate/premium features we use today? So technically, everything we use today was either a premium or free feature.
Free. Yep.
One little caveat to that is you'll notice if you go and look at if you create a new merge request after you've added all those security scanning jobs within this ultimate group, you will see that you get the results of those security scanning jobs in the UI. So the difference between our security scanners running on free versus ultimate is in free, you get the result as an artifact, and you don't get the result within the UI. I guess additionally, advanced SAST scanning is an ultimate feature. So our SemGrep-based scanner is the one we used primarily for free. Merge code owners, I think, are premium.
Yeah, code owners, merge approvals, and merge trains are premium and ultimate.
Cool.
You could just double check on code owners. I think, yeah.
Yeah, I just checked. It was premium. Okay, is there a possibility to have merge trains with really small tests on the first MRs and really big tests on the merge result pipeline, only triggered from previous MR changes? Merge trains with a really small test on the first MR. Okay, so
We can take
test.
over because I was just answering that question, if you don't mind.
Go for it.
Thank you. So hi, I'm back. So yes, that would be possible. What you can do is you can leverage the CI pipeline source variable. I will send an example at that question, but what you can do is if you use the rule set, you can have something like if CI pipeline source is merge request event for the merge request, and you also have the source merge train event, which you can then use for the smaller test data on the merge train. I'll send the example over in the Q&A section as well, so that you can copy it and play around with it in your demo environment as well.
I mean, I think technically you should just send it as the general chat so that everyone can see it, not in the Q&A.
Indeed. Yeah, we'll do that. I thought everyone has access to the questions, but yeah, you're right. That might be a better idea.
I don't know. I didn't even
Just to be sure.
also. Okay, a couple more minutes if anyone else wants to ask some questions. You have the whole team here, so it is a good chance.
In the meantime, you did not share the results. Did you share the results for the key initiatives for 2025
I don't think so.
for the poll?
Okay, if whoever's in charge, if Helena, if you, oh, there we go. Okay. Oh. Yeah, so these are the results for the key initiatives in 2025. This is interesting. I thought reducing security and compliance risk would
Oh,
be higher, but
Claire, we are not able to see your results because you only share your Chrome, I think.
I am sharing my whole screen, I thought.
Or maybe we can't see it because Zoom doesn't allow it to share the results.
Perhaps. What about now?
No.
No? Okay, well, Helena, if you know how to share these, we can go ahead and do that. Otherwise, I'll just read them off. 40% of you said that increasing operational efficiency was most important. 24% said delivering better products faster was most important. 24% said reducing security and compliance risk was most important. And 12% said just keeping things running as they are and looking to improve later in the year. So I thought that was interesting because I feel like a lot of the time reducing security and compliance risk is higher. But if we look back to the other question, which talked about where people are on their DevOps journeys, a good majority of people said they were just starting out. So it makes sense that we are at the stage where people are looking to increase operational efficiency. And coincidentally, premium is the tier that is more closely tied to those goals. And then ultimate tier is the one that we look at usually when looking to reduce security and compliance risk. So if you're one of those 24% of people that are trying to reduce security and compliance risk as your key initiative, you might want to talk to, if you have an existing account rep at GitLab, or you might want to reach out to see if you could get a demo or speak to them about GitLab Ultimate. It is a really powerful product, in my opinion.
All right. I think we are done with everything, right?
Yeah, that is the end. And
Yeah.
the Q&A is quiet. If anyone has any questions and will need us to respond, feel free to reach out to your account team or reach out to any of us on LinkedIn, and we'll be very happy.
Yeah.
So,
And yeah, as we already mentioned, you will have access 2 days after this session to your environment, to your lab environment, and we also will provide you the recording afterwards. So thanks for joining, everyone. Have a good Tuesday, and yeah, hopefully we see you in another workshop again. Thank you. Bye.